Hey y'all, in this video we're going over question 3 from your test study guide. So in this question we have a caveman throwing a rock into the air at a velocity of 10 meters per second, and it takes 20 seconds to go up and back down to the ground. You just have a little diagram of that here. And just to label the information we know to begin with, we know that initially he is throwing it at a velocity of 10 meters per second, and it's taking 20 seconds to go up and back down. So if you divide that in half, since it's starting and ending at the same height, it would take 10 seconds to go up and then another 10 seconds to go down. Okay. So for part A, it wants you to sketch a velocity time graph for this, and I'm just going to draw this down here. So when I say sketch the graph, what I'm asking you to do is only label the key numbers. I don't need you to label the entire axis in even increments. I just need the important information. What I'll be checking for is those important numbers as well as the correct shape and placement of the line. So to sketch this one out, we want to show that we are going in the positive direction for the first 10 seconds, the negative direction for the second 10 seconds, because it's going up, we consider positive direction, and down, negative direction. We also want to show what it's, the fact that as you throw something in the air, it's going to slow down as it reaches this highest point and then speeds back up when it hits the ground, just like you would if you tossed a ball into the air. So we want to show that in our graph as well. So when we get to our velocity graph, for positive direction, we want our line to be above the x-axis, and then the second half, we're going to be below the x-axis. And then for slowing down, we want to be going towards the x-axis, and then for speeding up, we want to go away from the x-axis. So I've labeled my 2 time intervals of 10 seconds and then ending at 20 seconds that it goes for total. And then for the first 10 seconds, I'm going to be in the positive direction. So I'm going to be above the x-axis, and I'm going to go towards the x-axis to slow down. Because right here at the top, my velocity is momentarily 0 meters per second. Right? Then for the second half of this movement of going down, it's negative direction, so it's below, and it's speeding up, so it's going to go away from the x-axis. The last thing that I want to label is my y-axis. I want those key numbers on there. And initially, I was given that initial velocity of 10 meters per second. So that's easy to label. The hard one that you have to possibly think more about is this bottom number that I'm going to want you to have on there. And in this case, we are starting and ending at the same height. And if you're not sure if it's the same height, it does say in the air and then back down to the ground, and the picture shows same height. It would be pretty obvious that it's, caught higher than it was launched or landed lower than it was launched, something to give an indication that they're not the same height. So when they are the same height like this is, the initial velocity will be the same as the final velocity at the end here. So this was launched at 10 meters per second, it'll land at 10 meters per second. If they were different heights, then if it's caught higher, it would be less than 10. If it was caught lower, like if the ground was down here, it would be higher than 10. All right, so to go back to my label, I'm going to label this negative 10 meters per second. And then I am done with part A. Right? Now for part B, we want to make the position time graph. And we want to include that key information. So I'm going to have 10 seconds and 20 seconds as well. And then I am not given the height that it reaches. I can figure that out, and actually on the paper key I made, I realized I left that off of the key as I am making this video. But we're gonna see that up and down motion that it makes. So we're considering again that on a position graph, positive direction in the beginning is going up, and it's gonna slow down and then go back down to the negative direction, and it's landing at the same height it's starting from. What I left off of my written answer key is this height here, and how we can figure that out is the area of the triangle here. And this is actually question E that we're kind of skipping ahead to. I just didn't label it on the graph. So for question E, you're finding out how high I went, and that's going to be marked here, and you're going to find the area. So to do this, you're just going to do 1/2 times the width, which is 10 seconds, times the height, which is 10 meters per second. And then when you multiply that out, you're going to get an answer of 50 meters. So this is the answer for E. And then we're going to mark that here as well, that it's 50 meters is the height that it reached. So that's what I'm looking for when I say sketch a position graph. I'm looking for these key shapes that it's slowing down and speeding up. I'm looking that you have it going in the right direction. And I have these key numbers like the 10 seconds, 20 seconds, and the 50 meters here. Okay. Now for C, we are looking for acceleration. So the best bet to figure this out is going to be to use your velocity time graph, because if you have a velocity time graph, you can use the slope to find acceleration. So you're just going to do, trying to get my pen back to work, the slope here. So you can do the slope of the whole line, or you could do just a section of it. The slope continues the same the whole time. So it doesn't matter if you do half of it or all of it. I'm going to just go ahead and do all of it. And you have a slope. The rise drops negative 20 total, and its run is 20 seconds. So you're going to get an acceleration of -1 meters per second squared for that. Right. And now for the last one, for D, how long does it take the rock to reach the highest point? We've technically already answered this when we were making our velocity time graph. And that's going to be 10 seconds that it took to get to this highest point, because it went 10 seconds up, 10 seconds down. Now, if you weren't working with quite as easy of numbers, like so for instance, this one's going the same, launch in the same height as landing. Let's say you didn't have that where it's easy to divide and know, okay, it took 10 seconds up, 10 seconds down. What you could do is look at your velocity time graph, and normally you'll have the slope of your line at this point, like we did here. And then instead of setting it for the whole line, set it for just this first part where your rise would be -10, your slope is -1, and then you can solve for what this number is. And I think we'll do that later on another video as well. But anyway, that's it for question 3. Let me know if you're still confused on anything, and I'll be happy to help.